All right, we're starting with question number 21 for this video. All of these have to do with integrating without your calculator. So let's go. Number 21. It's somewhere there. There it is. Integrate from -2 to 2 the absolute value of x cubed dx. Recognize the graph of x cubed, and from -2 to +2, this area and this area, they're going to match, and when they do match, the answer is going to be 0. But if I do absolute value, this area is then reflected up. Now these two areas match, so we're going to set it up from 0 to 2. Just x cubed, no absolute value bars. So when I have absolute value bars, my first indicator is to graph to get an understanding of it. Anyways, we're going to double this area, and then that's what we're going to do. So add 1 to the exponent and divide, and then you plug in 2, and then you plug in 0. Now when you plug in 0, the answer is 0, and I don't even want to simplify it. It's done. 22. Integrate from 1 to 3, 1 over t squared. So my first gut is to do this, and then add 1 to the exponent and divide, and then plug in 3. Oops, that'd be 3, right? Subtract, plug in 1. Something like that. 23. This is a hook. Notice this is not a definite integral. So the hook I need is 2x minus 2. The hook that's there in the question is x minus 1. So I need a 1/2. Because 1/2 times this makes it x minus 1. So now it's equivalent. You could also see it by factoring. So you could factor out a 2 and get x minus 1 and realize that there's a 1 and what it became is 2. And then the answer is going to start with 1/2. The hook is going to be unhooked. And then you add 1 to the exponent and divide. And then plus c because it's not a definite integral. 24. Again, an indefinite integral. I'm going to write it as y to the 1/2, y to the -1. This is one where I see algebra. So I multiply. Oops, should I keep the sign? And I multiply, which means I add the exponents, which would be -1/2. And then after you do algebra, you add 1 to the exponent and divide, or the reciprocal. Add 1, divide, or the reciprocal, and then plus c. 25. It says use geometry to integrate this one. And that's part of a circle. So from 0 to 4, that's a trapezoid. You need to write this down, and then equals. I'm just doing it in the book. For a trapezoid, with this orientation, it's half the width, and then the two heights, which are 4 plus 2. And then this is a quarter of a circle. So it's pi. The radius is 2, and then divide by 4. That's it. 26. Use the first and second number lines below to sketch a possible graph of a continuous function. I'm going to do it right here. So I know I need to go from -2 to +2. I'm going to change colors for fun. What do I know? So I know at 0 is a minimum, at 2 is a maximum. At 0 is a minimum, and at 2 is a maximum. I also know concavity. So this is going to decrease, but it's concave up. And then at -2, it changes concavity. So it's concave up, then concave down, and then concave so concave up, concave down, and then concave down. That matches. There's a minimum at 0 and a maximum at 2. There's one. And this picture could be shifted up or down. Calculator. I love calculator. Where's my calculator? All right, so find the average value for number 27. So to find average value, that's an integration question. From 1 to 4, and then divide by the difference of the bounds. So that's what I'm going to put in my calculator. So I'm going to divide sign, then menu, calculus, integrate. It's going to go from 1 to 4, and it's log. Leave that empty, just x. And then in the denominator, the difference of the bounds, control enter, and I get 0.368. The log button, LOG button, is right there with 10 to the x. It's on my finger now. All right, 0.368. There it is. 28. Find the x value that produces that average value. So you take log x and make it equal to 0.368, and then see what that answer is. So now we're solving an equation. So menu, algebra, solve. And the equation we're solving is log, leave that blank, x equals. Now to be accurate, I'm going to highlight this, and I'm going to go Control C to copy it, and then I'm going to paste it in. That way I'm super accurate. So Control V, and then comma X. So we try our best to round when it's the end of the question. If it's in the middle, if we can copy paste a full number, that's better. 2.335 or 336. Last question. It says, use the acceleration graph at the right to find the following for an object moving forward. So this is acceleration. So we're going to think, right? And so a at 1 just means, oh, the acceleration's 0. And the unit would be, oh, sorry, a at 1 is right here. Sorry, I was at there. A at 1 is in the middle. I need to know the equation of that line. So what's the slope of that line? Up 5 and over 3. And the y-intercept 0. So that's the equation. So when I plug in 1, the answer is 5/3. And the units are meters per second squared. In B, what's the acceleration at 6? That's a horizontal line right there, so it's just 5. And it's 5 meters per second squared. For C, what's the acceleration at 9? That again is in the middle, but I think I can find it exactly. So at 9, it looked right there, it's 1 meter per second. And then D, A at 12, that's at the end here, it's -2 meters per second squared. Just looking off the graph, pretty simple. E, what's the velocity at 3? So to understand that, we need to integrate. So at 3, that's a triangle. Now do they, oh, here it is, sorry. So they do give you the initial velocity. That's what I was looking for. So the initial velocity was 2. So let's go back to the beginning. If I want to know what the velocity is 3, I need to know a point or something about the velocity. So it's initially at 2, at 0, and then I want to find at 3. So I'm going to integrate the acceleration to find the velocity at 3 using this. So that's this triangle from 0 to 3 that I was starting. So the base and the height, so 3 and 5. So 1/2 times 3 times 5. And then the unit would be just meters per second. The next one's v at 7. I'm just going to do the same idea. So it's 2. And then we're integrating from 0 to 7. Now we already did 0 to 3. That's this answer here. So to go all the way to 7, there's a rectangle I need to add to it. So the length and the height, width and height, so that's 4 by 5. And that's meters per second. G says, hey, what's the velocity at 20? No, 12. And that's everything. We have to be a little careful here because area below the axis is negative. So we just need to be aware of that as we work across. Oops, to 12. So there's the setup. So this is what we already know. So that's the triangle, and then that's the rectangle in the middle. And now what do we still need to do to understand this? And so there's a trapezoid right here. In fact, if I want to do it in 2, yeah, well, I can do it here. So this trapezoid, the width is 1, and it goes 1/2. The width is 1, and then the two heights. The one height is 5, and the other height is 2. You could break it up into other shapes too. Then you have a triangle. Now what I notice is this triangle above matches this triangle below, right? Half the base times the height, half the base times the height. So they're exactly the same. So that would just cross out. So I don't need to find this area because I know that would be 0. So that would be the answer right there. And that would be in meters per second. H, that was H. Oh, did I skip one? I skipped 10. So sorry, this was H. And then I skipped G. Which is what's the velocity at 10? So we start with our initial and then we're integrating from 0 to 10, the acceleration. So far we know this part. And that trapezoid. And then to 10, you have this triangle you need. All of it's above. So half the base times the height. And there it is. And that would be in meters per second. And again, just put parentheses in the unit and you don't have to simplify that. I. At what time from 0 to 12 was the object moving the fastest? And then justify your answer. So if I see the acceleration in terms of when the object was moving the fastest, draw a number line from 0 to 12 and recognize at 10 it changes from positive to negative. So that means 10 creates a maximum. At what time was it moving the slowest? And justify your answer. So that would have to do with the ends So the velocity at 0 is 2. The velocity at 12, if I added up the answer to part H, I'll do that for you. It's 33. So at t equals 0, it's moving the slowest. K, when was the object slowing down? When was it decreasing? That's when the signs match. And so here, the velocity, so when you find the area, it's positive area. So when the acceleration and the velocity match. So from 0 to 3, the acceleration's positive and the area, velocity is positive. So from 0 to 3, it's speeding up. Here it's the same. So here the signs change, right? So from 7 to 10, it's decreasing, but the velocity is positive. That means it's slowing down between 7 and 10. Oh, wait a second. Let me think it through again. So because it's an acceleration graph, everything above acceleration is positive. So when I look here, acceleration is negative. But when I find the total area up to 12, from 10 to 12, the velocity is still positive because we have more positive area than below. It's a bit of a tricky question. So from 10 to 12, the velocity is still greater than 0 and the acceleration is less than 0. And that's it, right? I'm done. Mr. G Math, over and out. You did your homework. I'm really proud of you. Until next time.